All right, so in this video, we're going to do examples 1, 2, and 3. Again, this is nets and pyramids. So the first part, we're just going to look at the nets. So determine whether each net will form a pyramid when folded to make a solid. If yes, name it. So looking at A, B, and C, we just have to think, if we were to fold on those lines, would we end up getting a 3D solid pyramid? So for the first one, this will create a pyramid. So if I were to name this, again, we name by the base. The base is a square, so this would be a square pyramid. Okay, looking at this next one, yes or no. So we have 1, 2, 3, 4, 5, 6. So this is a hexagonal base, and we have 1, 2, 3, 4, 5 triangular faces. So if I were to fold this, this actually wouldn't completely close into a 3D shape. So this would be no, and so that means no name. And then this last one kind of looks like the Triforce upside down, but this would also make a pyramid. So this would be a triangular pyramid. Our base is this triangle. So if I fold all of these up and in, I end up with a triangular pyramid. Okay, so we're going to move on. So we're going to name some things here now. So the vertex, again, is specifically the point at the top. So the vertex would be vertex E, and it's a point. So we'll label it with just the capital letter E. Lateral faces are all triangles, so we're going to name them. There's 4 total in this picture. So I have triangle EBC, triangle ABE, triangle CED, and triangle AED. And that's one way to name those 4. You can name them in different order as long as you're actually naming the lateral faces here. Okay, so let me real quick erase so you guys can see a little better again. So moving on, besides my lateral faces, I have my lateral edges. These are just line segments. So the way you would name them are as line segments. So I have line segment EB, line segment EC, line segment AE, and line segment ED. I also have base edges. So base edges are these lines that make the base, in this case the square base. So my base edges again are line segments. So I have line segment AD, line segment BC, line segment DC, and line segment AB. All right, so that's example 3 for this video. The base of each is a square, so these are both square pyramids. Find the slant height. So the slant height in this picture, L, is the line going from the vertex to one of the base edges. Again, it's a slant height. Okay, it's on the actual face, the lateral face. It's not the height of the pyramid, it's the slant height. So it says find it. So if you notice, the actual height, if I were to draw this out here, and the slant height, as well as this half of the base, make a right triangle. Okay, so I have a height of 8. If this whole part here is 12, that makes this part half that, so this is 6. And I'm looking for my slant height L. Okay, so if you remember, I have a right triangle, missing side, given 2 sides means I can use Pythagorean theorem. So we'll do 6 squared plus 8 squared equals L squared. That gives me 36 plus 64 equals L squared. L squared equals 100. Take the square root of both sides, and I get L equals 10. So my slant height for this one is 10. Okay, so we're going to do the same thing, more or less, for the second one, B. But first I'm going to go ahead and erase. So if you want to pause and copy this down, go ahead and do it. But for now, I'm going to go ahead and erase it so I have more room. Okay, so it says if the perimeter of the base is 160 units, find the height. So perimeter means all the way around that square base. So first I need to find each side length, so 160 divided by 4 would give me 40. So the base edges have a length of 40. Okay, again, if this is 40 here, this would be half of that, so that's 20. And it says find the height, so I'm looking for this dashed line h. So again, I can make my right triangle. I'm given a slant height of 29. The base of this right triangle is 20. Looking for height h, we set up Pythagorean theorem. So I can do 20 squared plus h squared equals 29 squared. If I solve for that, all right, I'll end up getting h squared equals 441. I'll take the square roots of both sides, and I'll get h equals 21. So for this one, the height of my pyramid is 21 units. And that's it for part 2.